Hi, my name is Julien Girard. I'm an astronomer and scientist at the Space Telescope Science Institute in Baltimore, where I'm sitting right now, and that's where we operate the James Webb Space Telescope. So taking pictures of exoplanets is very difficult because they are very faint and they are usually next to a star which is very bright. So what we do is that we put a small mask and we block the light of a star so that we can see very faint stuff around it. So it can be a disk, it can be an exoplanet, or it can be several exoplanets. JWST has two instruments with coronagraphic capabilities, NIRCam in the near-infrared and MIRI in the mid-infrared. So they do have those masks to attenuate the light from the star and see faint stuff around it, which can be a circumstellar disk or exoplanet, or maybe even several exoplanets. So to get this to work, and that's what we call the commissioning of each observing mode, each way to use the telescope. So I was in charge of the NIRCam coronagraphy. We had to show that we could place the star exactly behind the mask to an accuracy that's really, really difficult to get. And so we had to understand the instrument very well so that we could basically perform that little move of the telescope to basically place the star behind the mask. And we ran into some difficulties, and for those reasons we were the last of the 17 observing modes to be declared science ready on July 11th this year. During July, the first exoplanet was observed directly, so we took a picture of that exoplanet, HIP 65426b. That's the telephone number, but it's going to be renamed by the community soon. That planet is 10,000 times fainter than its host star. It's only 10,000 times fainter because it's still young, and so it still shines a little bit. During commissioning, we did exactly the same measurement on a white dwarf that mimicked an exoplanet, and that was also 10,000 times fainter than the other star in the middle, right? And so that was the direct proof of concept. We managed to show that we could get this contrast of 10,000, or probably even 100,000. And so when we switched to the science target, we immediately, within a few hours, got the images of the real exoplanet. Yeah, so it's a very exciting time to be doing exoplanet imaging. We have very nice facilities, both on the ground. I used to work on ground-based facilities, and now, since 5.5 years, I work on the James Webb Space Telescope and also on the Roman one. Yeah, it's very exciting because right now we image very young planets, planets like Jupiter, like giant gaseous planets, because they shine and they're still quite big and hot. One day we'll be able to observe slightly smaller or colder planets, in particular with James Webb. And one day with the future missions like Roman, we will see exoplanets in reflected light, just like we see Jupiter in the night sky. And that will be at visible wavelengths, like more like we can see with our eyes. And even further in the future, hopefully, with bigger telescopes and more advanced technologies, we'll be able to see directly Earth-like planets.